This problem gives us a system of two blocks and a rope. The first thing it asks for is its acceleration. Let's start finding this by drawing a free body diagram of the whole system. I'll outline that here with a dashed line. There are two external forces that act on this system. First, there's its weight, the combined mass, times g, the acceleration of gravity, and there's the upward force F of 200 newtons. Newton's second law tells us if we add these forces, it will give us the mass times the acceleration in that direction. Adding the forces from the free body diagram gives us F minus the weight, minus because the weight is down, and that equals the system's mass, the mass of the thing we drew in the free body diagram, which is the sum of the masses, times A. Solve this for the acceleration A. And substitute all the known values. The sum of the masses, ma plus mb plus mass of the rope, is 15 kilograms. And when you calculate, this equals 3.53 meters per second squared. That's the acceleration of the whole system. Part B asks us for the tension at the top of the rope. Let's start finding that by drawing a free body diagram of the top block, block A. There are three forces acting on that block. First, there's the upward force F, the 200 Newton force. Then there's its weight, pulling down, and there is the tension at the top of the rope, also pulling in the downward direction. If we sum the forces in the y direction, it equals mass times acceleration. The left-hand side comes from the free body diagram. The force F is positive, the other two forces are negative, and they equal the mass A in this case, because that's what our free body diagram was of, times the same acceleration we just calculated. Solve this for the tension at the top of the rope, and substitute all the known values. To find that tension is 120 newtons. Now that we've solved parts A and B and run out of room, let me gather those two results up here. And erase all the rest of this so we have room to solve part C. Part C asks us for the tension at the rope's midpoint. To find that, let's draw a free body diagram of this system's top half. I'll outline it here in green. So mass A plus half the rope. There are three forces acting on the top half. The first is its weight, the mass of block A plus half the mass of the rope times g. The tension at the midpoint is also in the downward direction, and that 200 Newton force F is still in the upward direction. If we add all the forces along y, it equals mass times acceleration in that direction. Adding the forces comes from the free body diagram. Force F is positive, the other two are negative because they're down. And that equals the mass of what we drew the free body diagram for, the top half, A plus half the rope. Solve this for the tension at the midpoint. And substitute all the known values. Finding that the midpoint tension is 93.4 newtons.